Okay. So on the basis of lattice energy, we would be deciding whether you have a strong ionic bond, ionic compound, or weaker ionic compound. Okay. Let's suppose if you have more negative lattice energy, this is very important to know. If you have more negative lattice energy, that would be a stronger ionic solid, a stronger ionic compound. And if you have less negative lattice energy, so means that this would be weaker ionic compound. Okay, weaker ionic compound, right? Okay, so let's suppose sodium is having lattice energy that is equal to -707 kilojoules per mole, and magnesium chloride is having the lattice energy that is equal to 1400 kilojoules per mole. I can say that this is weak ionic solid and this is a stronger ionic solid. As I told you, the magnitude of lattice energy, okay, the magnitude of lattice energy, magnitude means the value. Magnitude means the value. Magnitude of lattice energy is directly proportional to strength of ionic solid. Strength of ionic solid. Okay. More negative means stronger ionic solid. Less negative means weaker ionic solid. Means more energy is released. It's mean that the compound would be stronger. So after looking at the lattice energy, you can tell this is weaker and you can tell this is stronger. Okay. But the thing is, you have to you have to know, you are supposed to know why this is stronger and why this is weaker. Yes, we have decided on the basis of lattice energy, okay, that this is stronger and this is weaker. So let's suppose if you are going to elaborate this, so you can say that magnesium is in group 2, so it's having +2 charge, and chlorine is in group 7, it has -1 charge. And if you talk about this sodium chloride, so sodium chloride means that sodium is having +1 charge and chlorine is having -1 charge. Okay, so we have discussed higher the charge, okay, like higher charge means that strong attraction. Higher charge means that strong attraction, and this is strong ionic solid. And vice versa for lower charge. Vice versa for lower charge. Okay. Vice versa for lower charge. Okay. Then Abdul Hasib, can you tell me this? Yes, Abdul Hasib. Which one is supposed to be stronger and which one is weaker? Yes. And Subhan, you as well. Can you tell me this? Yes. Aluminium is stronger. How can you say that aluminium is stronger, Hasib? How can you say that? Yes. Subhan, what do you think? Abdul Hasib, just higher charge. Okay. Okay. Subhan, what do you think, Subhan? सुभान जल्दी बताओ, आवाज आ रही है ना सुभान? Shamim, what do you think, Shamim? Yes, Shamim. Shamim, where are you? Hello, can you all hear me?
Yes, sir.
So I'm asking something, beta. At least you are supposed to reply. Hmm?
Is aluminum oxide stronger
Why?
because of higher charge and magnesium oxide
Exactly. So
has
aluminium
positive
is
charge?
stronger as this is plus 3, this is minus 2, this is plus 2, this is minus 2. It's mean that aluminium oxide is stronger. Aluminium oxide is stronger, okay? And magnesium oxide is weaker, right? Okay. Okay. So then um what is the definition of lattice energy? What is the definition of lattice energy? How can I define that? What is lattice energy? So remember, lattice energy is always, it's always negative, it's always negative, it's always exothermic, it's always exothermic, it's always negative. Why? This is bond making. Why? This is bond making, right? So bond making is exothermic. Remember, I'm using the word always because we have some processes which are, which may be exo, which may be endo, right? So we have to you can say specify those processes which are always exo, or I can say that which are always endo. So there is a difference between them, okay? So I can define lattice energy as it's the energy released. Just look at this: energy released, okay, when when one mole of when 1 mole of uh, ionic solid is formed from gaseous ions, from gaseous ions under standard condition. Means I have to make this, okay, sodium chloride solid, sodium chloride solid, okay. So I need this according to the definition, and I need this according to the definition. Obviously, the energy that is released would be the lattice energy, but negative. Okay. Uh, Now the question is, sodium is in this form is unstable. Okay. Sodium doesn't exist. Sodium that doesn't exist in ionic form. Okay. Although I would be having this. This is the standard state of solid. Okay. This is stable in this form. Again, I can say that chlorine doesn't exist in chloride form, as this is charged particle, so this is highly unstable. Although this is its stable form. This is what? Stable form. Okay. Now my question is that I have to convert this sodium solid into this, and I have to convert this chlorine gas okay. So we have to convert this. I would be giving you this, and you would be converting this sodium solid into this. I would be giving you this Cl2 gas, and you would be converting this Cl2 gas into 2Cl minus. Okay. So just look at this. Just look at this. First of all, in step one, I would be converting this sodium solid into sodium gas. Into sodium gas. Can anyone tell me what's the procedure? Like, what's the process? What's the name of the process if we are going to convert the sodium solid into the
Sublimation.
sodium gas? Yes, this is
Sublimation.
called no, Shamim, no.
Pure
Yes,
atomization.
exactly. This is atomization. This is atomization. Okay. And then step number two. Step number two. Okay, can you tell me atomization is exothermic or endothermic? This is also very important that you must know this, because examiner would be asking the nature of the process, whether this is exothermic, whether this is endothermic. You must know this. You must know this. This is mandatory, remember, okay? Okay, can you hear me?
Yes.
Yes, okay. And then um, once you have converted the sodium solid into the sodium gas, once you have converted the sodium solid into the sodium gas, then in the next step, I would be converting this sodium gas into this. Okay, let me ask again the nature of the process, but after this, can you tell me what is the name of this process? Can you tell me what is the name of this process? Yes.
Pure ionization.
Exactly. This is ionization. This is ionization. This is ionization. Okay. Yes. Now, can anyone tell me, is this exothermic or endothermic? And also this, exothermic or endothermic? Yes, can you tell me this?
And
Sorry, Shamim, you are lagging. What are you saying?
So both exo and endo.
No. Only one thing. This is the hint for you. It's only one. Whether exo, whether endo.
endo.
Yes, Subhan, what do you think, Subhan? What is this?
Is it endothermic?
Endothermic. Okay. Subhan, what do you think? Tala, what do you think? Shamim, what do you think? Sahil, what do you think? Yes. Just try. This is very easy, man. Your voice is having echo. Okay, let me tell you. Let me tell you. Okay. Why this is endo, Subhan? Why this is endo, Subhan? Muhammad Hasib is saying endothermic because solid to gas. Okay. Remember, beta, remember always, in the solid state, the particles are tightly packed together with a very strong force of attraction. And when you are going to provide heat, it's mean that you are going to overcome the force of attraction between these particles. So obviously your energy would be absorbed by the particles so that they can be separated from each other. So that's why I can say that this is always This is always endothermic. Always endothermic, right? And can you tell me what is ionization? Is this endo or exo? And you have discussed it in AS, right? In atomic structure. Remember, this is not new thing for you guys. This is the old one that you have discussed. Yes, can you tell me is this exo or endo? Yes. Uh-huh. Hmm.
Is it exo?
Oh, exo. Hasib, what do you think? Tala? Oh, sorry, Tala. This was Tala. Sahil, what do you think? Shamim, Subhan. Yes. She was saying exo. What do you think? Oh, Sahil is saying endothermic. Sahil, why? What's the reason, Sahil? What's the reason? It's also endo because requires energy. Okay. Yes. Yes, you're right. You are right. Why? Because if you remember, we used to discuss the energy which is required to remove electron from the outer shell of a gaseous atom. The energy which is required to remove an electron from the outer shell of a gaseous atom. So that's why, remember, this is always endothermic. Yes, Shamim, you are right, because it's from gas to gaseous ion. Yes, endo, always endothermic, always the energy would be required. See this. This is an atom, and this is a nucleus, right? And this is an electron. Okay, so electron is tightly attracted to this nucleus because oppositely charged ions attract each other. And you are going to remove this electron. You are going to remove this electron, right? You are going to remove this electron. So it's mean that you are going away. You are going away from the nucleus. Nucleus is having a force of attraction with this electron. How can the nucleus will allow you to take away this electron? Obviously the answer is a big no. So that's why you have to require energy. You have to provide energy. You have to provide energy so that the electron can be removed easily. So I can say that this process is always endothermic. So this is always endothermic, right? This is always endothermic. So atomization is always endothermic, and ionization is always endothermic. So yes, now Na plus is ready. Na plus gas is ready. Acha, some people think that why didn't you convert this sodium solid into this gas? I mean, why I have not converted this sodium solid into the sodium gaseous ion directly. Why? What's the reason? Okay, so the thing is that the definition of ionization energy says that electron can only be removed from the gaseous atom. Remember, electron can only be removed from the gaseous atom. That's why this is mandatory. This is mandatory to convert this sodium solid into the sodium gas so that you can remove electron easily from the outer shell of gaseous atom. Okay, this is the reason before ionization you are supposed to do atomization. Okay, before ionization you are supposed to do atomization, right? So yes, sodium positive gas is ready, but the thing is that we were making sodium chloride. We were making the sodium chloride, that is this. Okay, that is this. So to make sodium chloride, I need two ions, Na positive ion and Cl negative ion. So I have this Na positive ion, which I have taken from this sodium solid. After processing it, I have converted this sodium solid into the sodium plus cation. Now the thing is that I have chlorine gas, and I have to convert this chlorine gas into this Cl minus. Okay, I have to convert this Cl2 gas into this sodium positive cation. Once you have converted this Cl2 gas into the Cl minus gaseous ion, so then they would be combining with each other to form sodium chloride. Okay, so how can I convert this chlorine into Cl minus gas? Okay, Cl minus gas, remember. So again, step number one, that uh, you have to convert this Cl2 gas into Cl atom. These are two chlorine atoms. I have broken down the molecule. I have broken down the molecule into an atom, into an atom. This is also known as atomization. This is also known as atomization. Okay, this is also known as atomization. Atomization is not only used for the solids, for the metals. No, no. This can also be used for non-metals. This can also be used for non-metals. For metals, we were converting from solid to gas. For non-metals, you are supposed to convert the molecule into an atom. So there is a difference. There is a difference. Okay, this is a broad definition of atomization. For metals, this is from solid to gas, and for non-metals, this is from molecule to atom. In both processes, you are going to atomize, right? So I have given you chlorine molecule, Cl2 gas. Okay, then what you have done basically, you have converted this chlorine molecule into the two chlorine atoms. Okay, so now step number two. Okay, in step two, I have this chlorine atom. I have these two chlorine atoms. Okay, so what I do basically, I would be converting this chlorine atom into the Cl minus, What does it mean? What does it mean? It's mean that gain of electron. It's mean that gain of electron, right? It's not the loss of electron. When something loses electron, it forms cation. When something loses electron, it forms cation, positive ion. But it's not a loss of electron, it's the gain of electron. So chlorine gas, chlorine atom chlorine atom is going to gain electron, okay, and then it should be converting into the Cl minus gaseous anion. Okay, so this is mandatory. So first of all, you have converted the sodium solid into sodium positive gas, and then in the next part you have converted this chlorine molecule into the chlorine atom. Okay, and then chlorine atom into the chloride ion after gaining electron. So for sure you don't know the name of the process, because this was not the syllabus. In AS syllabus, this is called electron affinity. We would be discussing this is electron affinity. This is electron affinity, right? This is electron affinity, attraction towards electron. What was ionization? It was the loss of electron. This is the gain of electron. Ionization is the loss of electron. Affinity is the gain of electron. It's opposite to the ionization. It's just opposite, right? Ionization was the loss and affinity is the gain. Okay, so there is a difference. Remember, this is the new thing for you. And okay, I told you the atomization, that this is an endothermic, but the thing is that we would be discussing the nature of electron affinity, because this may be exothermic and this may be endothermic. We would be discussing in detail, right? Okay, so the thing is, now Cl minus is ready. Cl minus is ready. They will be combining with each other. To form sodium chloride solid. The energy that is released, that would be called lattice energy. The energy that is released, that would be called lattice energy. Okay, so in this way we would be making, okay, ionic compounds, right? Okay, so you must know different processes that are involved in this, you can say, the whole scenario: atomization, ionization, and then electron affinity. Atomization, ionization, and then electron affinity. Okay, so I told you the definition of lattice energy, that was the energy released when 1 mole of ionic solid is formed from the gaseous ions. Okay, from the gaseous ions. Can you write down the lattice energy equation for the formation of magnesium nitride? Can you write it down? Yes. Then I would be writing, then you are supposed to match magnesium nitride, magnesium nitride, magnesium nitride. Let me tell you the form. Can anyone tell me the formula of magnesium nitride? Yes. Can anyone tell me the chemical formula of calcium or magnesium nitride? Yes. Mm-hmm. Easy. Yes. Magnesium nitride. Yes. Mm-hmm. Yes, can anyone tell me? No? Don't know about that? This is very easy. Mg3N2. Oh, Faisal, nice. This is Mg3N2, yes. So you have to write down the lattice energy equation for the formation of this ionic compound, that is magnesium nitride. Fast. I'm going to give you 30 seconds, then I would be writing, okay? Fast. Of magnesium nitride, so you are supposed to write Mg2 positive and nitrogen is 3 minus. Okay, because magnesium is in group 2, so what those elements which are in group 2, they are supposed to have +2 charge, and those elements which are in group 5, they are supposed to have -3 charge. Okay, so they would be attracting with each other to form this ionic solid, that is magnesium nitride, Mg3 and 2. In the same way, in the same manner, you are supposed to write this. So you would be writing down just like that. To balance this, I'm supposed to write 2 over here and I'm supposed to write 3 over here. This is the lattice energy equation. Why this is the lattice energy equation? Because 1 mole of an ionic solid is formed. Remember, 1 mole, 1 mole, 1 mole, 1 mole. Not 2, not 3, not 4, then 7. No, only 1 mole, only 1 mole. So 1 mole of ionic solid is formed from the gaseous ions under standard condition. The energy that would be released as a result of this would be called lattice energy. Okay, right?